Welcome back to 3D Decode. In last video, we gave a quick overview of bearings and seals in API 617 compressors. Today, we're going deeper, because these topics are not only hot interview questions, but also critical in real design work. Let's start with bearings in API compressors. Bearings are what keep the rotor stable, allowing smooth rotation with minimal friction. Types of bearings in API 617 machines: journal bearings, radial bearings, hydrodynamic, oil film based, carry radial loads, rotor weight plus unbalanced forces. Critical point: oil film thickness must always prevent shaft to metal contact. Thrust bearings handle axial loads caused by pressure differences across impellers. API standard design equals tilting pad thrust bearing. Pads self-align, forming a stable oil wedge. Handles heavy thrust without wear. API requirements for bearings: replaceable without disassembling the compressor casing. Designed for continuous operation at rated load, plus 10% overload. Must survive short-term oil film loss without catastrophic failure. Next topic: sealing systems in API compressors. Seals prevent process gas from leaking into the atmosphere or oil system. While API 617 defines sealing requirements, most details now live in API 692, which covers dry gas seals. Seal types: labyrinth seals. Non-contact, series of teeth restrict gas flow. Common in balance piston and interstage locations. Simple and low maintenance, but some leakage always occurs. Dry gas seals, DGS. Modern non-contact face seals. A thin gas film separates rotating and stationary faces. Preferred for hazardous gases like methane or hydrogen. Require a dedicated seal gas system, API 692. Oil seals, older design. Use oil to block gas escape. Rarely used today due to contamination risks. Next topic: seal gas and support system. For dry gas seals to function, a reliable seal gas system is essential. It ensures clean gas supply to the seal, prevention of process gas leakage, correct pressure balance across the faces. A typical system includes filters, pressure regulators, check valves, instrumentation to monitor leakage. Next, why this matters. Earrings and seals are the top reliability risks in centrifugal compressors. When they fail, you can face high vibration, oil contamination, dangerous gas leaks, expensive shutdowns. This is why API standards are strict, ensuring robust, safe, and maintainable designs. Next, move to mini quiz. You can answer in comment below 1. What bearing type carries radial loads in API 617 machines? 2. Which seal is most common in modern high-pressure natural gas compressors? 3. What's the main drawback of labyrinth seals? 4. Why must bearings be replaceable without removing the compressor casing? Practical task. As a quick exercise, sketch a compressor cross-section showing rotor, journal bearings, thrust bearing, dry gas seal at shaft ends. This will strengthen your technical understanding and help in interviews. Also, you can draw and post on LinkedIn and tag us or in comment section also. Next we see import at question for interview, mostly asked interview Q&A, day 3. Q. Why are tilting pad thrust bearings used instead of flat thrust bearings? A. They self-adjust to form a stable oil wedge, reducing wear and handling high loads. Q. What's the difference between labyrinth seals and dry gas seals? A. Labyrinth equals flow restriction with some leakage. DGS equals controlled gas film with near zero leakage. Q. What's the role of a seal gas system? A. Supplies clean, pressurized gas, prevents leakage, and ensures reliability. Q. What if rotor thrust exceeds the thrust bearing's design? A. The bearing fails, rotor contacts the casing, and catastrophic damage can occur. That's all for today's API 617 deep dive on bearings and sealing systems. If this was helpful, Don't forget to like, subscribe, and share your thoughts in the comments. This is 3D Decode, where we simplify complex engineering topics. See you in the next video.